Alright, morning announcements are late. Probably will get interrupted here shortly, but I'm no longer waiting on. So, today we're going to discuss a very important topic. So, in programming, there are variables, there are loops, and the next thing is there are arrays or lists. And these build up the core mechanics of programming. List. So the first 5 activities ask you to work with individual turtles and variables, which is also useful to know how to group similar types of items together. For example, if you are representing animals in code, you might want to group animals according to similar properties. Even different animals like dogs and cats can be grouped to capture their movement, temperature, eating, sleeping habits, and describe physical properties such as fur color. In Python, we group data types with a construct known as a list. You will probably hear me call this an array because almost every other programming language calls it an array, and list and array are somewhat distinct. So here in Python, it'll be called a list. A list is an ordered collection of items. For example, value 1, value 2, grouped together describes a list where value 1 is the first element, value 2 is the second element, and so forth. In other programming languages, it's called an array, which is an ordered collection of the elements. This is probably going beyond the scope of the class, but in C++, which is the programming language I like, I'll make it 3 items. So in C++, can y'all see this? We have an array. Can you see that? Okay. Sometimes I don't know if it's on my screen only or the TV. So we have an array, and in memory and natural RAM of the computer, an array is continuous. Every item is connected together in one spot. So everything's in a row. In C++, we have something also called a list. Let's see if I can do it like this. In which case we have so in other languages, this is probably what a list, the difference between a list and an array. In Python, they call the array a list. But we can see that these are ordered, meaning that this was 1, this is 1, this is 2, this is 2, this is 3, and this is 3. So we have in a list an array of different items. They both contain 3 objects, but you can notice that list isn't continuous. Instead, once we list the first object, it will point to the next object. And after you read this object, it'll point over to this one. So they could be in different spots of RAM. It's just that after you read the first element, it'll point and tell you where the next one's located in RAM. There's advantages, but in this class, we don't care how the list is actually made or in RAM. You'll use it the same way. You access the first element, and you can access the second element. It's just that in some programming languages, this is very slow, but it allows you to delete something very easily. For example, again, this is for high level stuff. You don't really need to know this, but let's say that I wanted to delete the middle one, number 2. It's very easy to delete something out of a list because all you have to do is come over here, delete it, and then draw where this is pointing at. So all I did was change that 1 is now pointing to 3, and you deleted number 2. In order to delete something out of an array, what you have to do is create a new array that's of size 2 because they have to be next to each other. And then you copy, delete this, you copy the old array values over to here. And then you delete the old array. As you can imagine, this can be quite slow. The difference, though, between and other high-level programming languages like C++ is that it's really fast to access things close together versus far apart. This has to do with the fact that you load it into RAM. RAM loads it into the cache. You've probably heard of when looking at CPUs that you have some sort of cache. And then and the cache things that are next to each other are all loaded at the same time. So this entire array can be loaded into the cache, whereas usually this would maybe not fit in the cache and will cause your program to be slower. But if you have a very large list and you're constantly removing things from it, this might be faster. It really depends, but we don't care about speed. We only care about, in this class, actually getting something to run. And in Python, it doesn't matter. A list is called an array. So in Python, a list would have been continuous. So anything can be grouped together into a list. Numbers, words, fruits, animals, colors, and even turtles can be made into a list. In this activity, you create and manage multiple turtles using, at the same time using a list. So let's see the notation of a list. So again, I won't have it up now, but I'll have it within the next hour or so. The actual assessment and stuff. But what do you think this code does below? Yes. So it prints a list of this. So it just printed what the list was. So we have a list here. Because they're strings. So in Python, there's no difference between a double quote and single quote. So I could have changed this to a single quote to represent a string, and it doesn't do anything. In C++ and other languages, there is a difference. You have to use double quotes for strings. Because in Python, the default is single quotes, which is horribly wrong. So the reason why these people use double quotes here is because to match other languages. But Python is meant to do single quotes, so they just output single quotes. It's weird, I know, but it's the language of choice. What would you think happened if I put brackets here and did 1? Or let's make it 2. What do you think this would do before running it? It printed mouse. What do you think this did? Yes. So in programming, we begin with 0. So the 0th term is dog. The first term is cat. The second term is mouse. Third is bird. And fourth is monkey. So in programming, lists begin with index 0. So if I wanted to print the 0th term, it'd be dog. If I wanted to print the first term, it'd be cat. So if you guessed that it's going to display a list in the Python terminal, you were correct. The first line of code created the list. So the syntax of a list is going to be these square brackets separated by commas. Yes. Square brackets. So the variable name is new list. Square brackets contains all the elements in the list. Each item is separated by a comma and called an element. So this is an element of the array. The second line prints out the list created. So if you go take like an AP test, which we don't offer it here, the College Board on a test, indices begin with 1, which is confusing because almost no programming languages begin with 1. They always begin with 0. This creates an empty list. This copies list B into list A. This initializes list A with these values. So if you want to append something to a list, you would do dot append after the list, and it'll add it to it. Whenever you append or add something to a list, it will always add it toward the end. And you use this syntax here. So whatever your variable name is, you do dot append, and it'll append whatever you provide it onto the end of that list. So here we have our list: dog, cat, mouse, bird, monkey, and we're going to be adding lion to it. So running it, we can see our list is now dog, cat, mouse, bird, monkey, lion. The length of the list was increased by 1, and the value is placed at the end of the list. Note that the syntax for College Board's deal is they actually have a function called append. The first argument is a list you want to be appending, and then comma value too. So it takes value and appends it to this list using this function. Yeah. So in Python, array and list are the same thing. Going back here, what other languages do, because this has to be continuous in another language, it'll check to see if there's enough space to allocate this. If there isn't, then it will come over here and create a new one. So it checks to see if there's enough space to add it right here. If there isn't enough space, it'll have to create in memory a brand new spot and then copy this over. Oh, you would actually know. What you would normally do is maybe you have a text file containing a list of. Maybe you have a text file containing this, and you want to read from that file. And what you would do is while. So what you do, I'm going to use pseudocode. Is what you do while still reading file, read, or I should say line equals read next line from file. And then what you want to do is new list dot append line. And so I'm in a while loop reading a file, and every line from that file, I'm appending it to a list. So if I wanted to save this to the computer, so that the next time the program starts, I can read it from the file. So currently we haven't been doing this. Every time you run a program, it starts over fresh. But what if you want to save? What if you're building a game and you want to save a list of high scores? So that means that at the start of the program, it will go in and get the list of scores, and and it would read it from the disk from your hard drive, and then it would re-pull up the list, and you can see all your old previous high scores. We'll be doing that for one project or one activity. So after creating a list, you can add to it. It's not permanent. It's just a variable. Variables can be changed. So we can append to it. What if you want to get the last item that was placed in the list and remove it? So much like you want to grab the top item out of the master bag, you can use something called pop. So what pop does, let me show you. Let me remove lion and do this. While new list dot, I think it's link. I don't remember the syntax. Let me do that. I don't think it's that. I think it's len. I think it's a function. Length of array Python. How do you get a length of it? Yeah, it's len. So while length of array is greater than 0, what I'm going to do is list is now this. Alright, let me do this. So original list is that. Item equals new list dot pop. Print item removed is item, and do this. Alright, so our original list is dog, cat, mouse, bird, monkey. I removed monkey, so I popped it out. And the list is now dog, cat, mouse, bird. So I removed monkey from the very end. I can pop out the next item at the end, bird, and it now removes this. So now I only have 3 items, dog, cat, mouse. If I call pop again, it'll pop out mouse, and the list is now dog and cat. If I call pop again, it'll remove cat, and the list is dog. And if I do pop again, it will remove dog, and now the list is empty. So pop will get the last item and remove it at the same time. Yes. So remember that. So let's say that you don't want to remove it. Let's say that I want to get the last item from the list and not get it. So this is number 0, 1, 2, 3, 4. How many items are in this list? So the length of this list is 5. And what is the last element will be? 4. So what would that be? So I could do print last element, and I can do new list, and I can use these square brackets to access a specific item. So if I do 4, this is not pop. This is oh, why is it doing that? Can't run it. Yeah, but I didn't want to mess it up. Let me go up to the very top. So if I did last element, and we said that it's 4, and that's how we get it. But what if we all wanted to just make sure I get the last? Well, I know the length, the last element is going to be the length minus 1. So I can do length of list minus 1, and now I get it, and let me print the list. The list is new list. So here I accessed the last element, but I didn't remove it. Because I know the last element is going to be the size of the list, so there's 5 elements, and this index is going to be the length of it minus 1. So if you want to access the last element without removing it, this removes it always. Well then, if you wanted to remove the second to last one, you can pop 2 of them, and then reappend the last one back into it. Technically you can, there's things, but again, it's arrays, like I said, arrays and Python lists are not really meant to be removing things in the middle. And you can, but it's going to be better just kind of to create a new list. There's ways of doing it, but I don't think you'll ever need to specifically remove one. If you're going to be moving lots of them, it'll probably be better to break this up and make 2 new lists. You'll be just adding whichever ones you want to a new list. Yeah. So think of pop as popping an item off the list, and you always would do it from the very end. Although this example assigns a variable, you do not have to do so when you pop. In other words, you can just use pop by itself. So let's say that you didn't care. Let's say that you just wanted to remove monkey, but you didn't want to actually assign it to an item. So you could just do this, new list.pop, item would be undefined. But you don't have to actually save it to a variable anytime you want pop. So if you want to, for example, remove a list, there's better ways of doing this. But you could do while list is not empty, just pop over and over again. What you would want to do is there's probably a clear method. I don't know off the top of my head. So if I type in Python or Python list clear, yeah, you can do .clear, and it will clear. It will remove everything. So we've been looking at while loops. While loops are good and all, but there's actually probably a better loop to be using, and it's the for loop. So while loops are usually used if you don't know exactly when or how many times they'll execute. So you want to execute something while something is true. While the list is not empty, maybe perhaps if you're removing things from a list. But if you know exactly a certain number of times, so let's say that I know the size of the list, and I want to do it for all the items on the list. Once you have a list, it's common that a program needs to repeat a task for an item in the list. So you want to iterate, you want to go over the entire list. You want to loop over every element in the list. Generally, for loops will probably be good to do that for. You can construct something called a for loop. For loop is similar to a while loop as you iterate through the code. However, the for loop is different in that it tells the program to run through a list and each item in the list giving a task. So when you use a list, the for loop retrieves each item in the list and assigns it to a loop variable. Using the loop variable, you can have the program execute the same sequence for each code. In effect, the while loop variable can be assigned to each element of the list on each iteration. So one example. So this is a structure. Let me actually go ahead and get the code word for the day. So here's the code word. No. So that's the code word. So the structure for it, for a for loop, is you provide the Python keyword for, you provide a variable name, and then you provide the keyword in, and then you provide a variable list. So this is your variable. This would be new underscore list. And then here's the body of the loop. Oh, I realized I wasn't going. So for a variable you want to call every element, keyword in, and then the name of variable of the list. So for and in are keywords. Variable is going to be the new variable created for each element. List is going to be the list of the list you're going to be iterating over. And then every statement ends in a colon, every branch, like a for, a while, and if. You're going to do white space to indicate the code inside of it. So to indicate what code is in, or the body of the loop, do by white space. So examine the code in the code editor. Any code that is intended directly beneath the for loop is called the body of the loop. So the code that's inside the for loop we call the body of the loop. It will be executed for each iteration of the loop. Notice the for loop is notice how the for loop is written, with the loop variable assigned as an animal, and the code will run during the loop indented for the for statement. So if I wanted to iterate through all the animals in this list, so this is my list. It's called new list. So what I can do is for, and I create a variable. So this is going to be a new variable created. So for animal in new list, it will go and execute every animal, and it'll save it. So first, how this for loop works is first it's going to start at index 0, and it's going to save dog to this variable, and then it's going to execute the body. It's then going to move up to the next item, cat, and it's going to take cat and save it into this variable animal, and then execute the for loop. Then it's going to move to the next variable, save it to animal, and then execute the body of the loop. And it's going to do this for as many items are in the loop. So if I do this, you can see it executes dog first, then cat, then mouse, then bird, then monkey. Because I'm no longer accessing the list. It overwrites it. So remember, variables can be changed. So equivalent. So I can write this as a while loop. So I'll create a variable in, or I think y'all are using I. So I equals 0, while I is less than length of array. Then I'm going to save animal as new list I, and then I'm going to print animal. So these two loops right here are the same thing. Let's run it. No, they're not. Yep. So at the very end of the while loop, I do I plus equals 1. So here, first is this code: dog, cat, mouse, bird, monkey. This is how you would write it if you were using a while loop. Notice how much more code it is. This contains a lot more code. We have to increment the I to keep track of where we're at in the list. We have to create a new variable, I, so we can do it. We also have to keep checking the list, see if I is still less than the total number. And then this comes over here, gets 0, 1, 2, 3, 4, and saves it to animal. These two loops are the exact same thing. This is actually how this loop works, kinda. Except for this one's more efficient. This one will run faster. Because of reasons way outside the scope of this class. Because length is actually goes in and counts the length. For an array, it's pretty simple. But this is actually a function, so it's gonna have to execute this over and over. Does the size of the list change? So it might have been better to actually come over here and do size, and actually pull it out of the loop, and now execute it like this. Now I'm not executing this function over and over and over again. Does that make sense? So instead of having length of new list here, I moved it out so that this function length is called over and over again. But again, it's outside the scope of this class. I don't care about efficiency. Kinda. There's some things you can do for loops better. So again, this is Python. It's gonna be weird in Python. So for C++, this is not Python, but for C++, I could do for int I equals 0, I less than 10 plus I. I could do something like this, to where it creates a variable called I, starts at 0, and while I is less than 10, execute the loop. At the very end of the loop, I will increment I by 1. Again, this is C++. C++ is more powerful than Python. This would be the equivalent of doing int I equals 0, while I less than 10, execute the loop, and at the very end, increment I. And this increment I is I plus equals 1. But this notation is C++, and we're doing Python. What now? Yes, you're going to be using for loops. Yes. So run the program, and we saw that originally it executed this. Note that no longer puts quotations marks and actually does it by lines, because we're actually calling print by times. And prints it out individually instead of all at once. So this is doing individually instead of all at once. The for loop continues to execute as long as it has elements in the list. This repetition is called an iteration. The while loop also iterates. How many times does it iterate? It would be the size of the list for five times. Almost running out of time. The for loop assigns each element in the list. What is the loop variable in the code? The loop variable is called animal. In College Board notation, they did for each item in list. And they're closer to C++ than Python to do something like that. I think that's where I'm going to stop. So add the following indented line below the for loop. So and above. So you could do that. Next animal dog, next animal cat, next animal mouse. If you were to add 2 more print statements, use E20 because if you added 4, it executes 5 times. If you added 2 more print statements, you see an output of 20 things being printed because this executes 5 times and there's 4 print statements. We'll now look later tomorrow looping with a list of turtles. So we've been using one turtle only. Now we can create a list of turtles and control each of the turtles independently of each other. That's what we'll do tomorrow. That's it for today. Any questions? Any additional questions? Alright. So we'll do looping with list. Wow. I don't know if yeah, that's it.